So let's derive the distance formula for the distance between any 2 points on the plane. So to remind you what we're trying to accomplish, let's restate the distance formula. The distance formula says, given 2 points, one at coordinates x1, y1, and one at coordinates x2, y2, the distance between them is given by the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so let's start with what we're given, right? These 2 points. So say we have the x-axis on the y-axis, and let's have a point over here. Let's call that x1, y1, right? So the x value is going to be x1, and the y value is going to be y1, right? That's what it means for the coordinates to be as such. And then let's have another point over here, and let's say that that's at x2, y2. So again, the x coordinate is going to be x2, and the y coordinate is going to be y2. And what do we want to find? We want to find the distance between these 2 points. And the distance is always, the shortest path, so that's just going to be a straight line connecting them. Or my interpretation of a straight line, which is close enough, I guess, right? So you want to find what that line is. So the best way to do this is to make a triangle out of these extra points we have, right? So let's make a triangle. And notice that this is going to be a 90-degree triangle. So now we have to recall what Pythagoras told us in the Pythagorean Theorem, which basically states that if you have a 90-degree triangle and you have the 3 sides labeled, then we know that the way the sides are correlated is that if you take the sum of the squares of the 2 smaller sides, that equals to the square of the hypotenuse, which is the longest side. So we can use Pythagorean Theorem to solve for this, right? So first, what's the length of this vertical side here? Well, the length is just going to be the difference in the y's. So the length of the vertical side is going to be y2 minus y1. And similarly, the length of the horizontal side is going to be x2 minus x1. So now let's put Pythagorean Theorem into play and call the hypotenuse that we're looking for d, right? Because that's what we want to find. We want to find the distance. So we know that the sides squared, and then we take the sum. So let's see. x2 minus x1 squared plus y2 minus y1 squared is going to be equal to d squared, right? That's what Pythagorean Theorem states. So then what we do, finally, is take the square root of both sides, and so then on the right, which I'm going to move to the left, we just get d. And then here, we get the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, so we found the distance formula, right? Now, just one last thing to note, there's little plus or minus distinction that should go here whenever we take the square root of something. But because we're talking about distance, distance is always going to be positive, no matter which way you spin it, right? So there's no point in putting the plus or minus, because we know it's always going to be plus. So there we go. We finally got our distance formula, and that's how you derive it.